Okay, so today we're going to be taking a look at arithmetic sequences, and we will not be discussing any series today. What is a sequence? Gave you a definition a couple days ago. So find it in your notes. A sequence is, so there you go. It's basically going to be a list of numbers. Okay, so a sequence is going to be a list of numbers created by a function whose domain is positive integers. And I do understand from the homework, there's probably, I would highly doubt that there would not be some questions that we took a look at yesterday where you were asked to come up with a general term that maybe you struggled with a little bit. They can be rather tough. But we're going to specifically look at one type of sequence today, which is arithmetic. So an arithmetic sequence, you're still going to have that domain of positive integers because, well, I'm using the word sequence. But arithmetic sequence is created by constant addition. So you have four basic arithmetic functions: addition, subtraction, multiplication, and division. Now that might sound a little bit confusing because I just said we're going to be taking a look at arithmetic sequences. But of those basic four arithmetic functions of addition, subtraction, multiplication, and division, repeated addition and subtraction, you can add by a negative number and effectively be subtracting. So when you have in a constant addition, a constant difference, which is what I'm going to be calling it for the rest of the lesson, you're adding by a common difference, then we're going to specifically identify that sequence as being an arithmetic sequence. If you have a list of numbers that are created by constant multiplication, and you could argue that division, like dividing by 2, is the same thing as multiplying by 1/2. So like subtraction really is just a type of addition. You're adding by a negative number. Division, you could argue, is just multiplication. You're just multiplying by a fraction. So constant addition will be identified. Any sequence of numbers or values that are created by constant addition, that is going to be arithmetic. If you have a list of numbers that are created by repetitive multiplication, that's going to be identified as geometric. And even though the beginning of this chapter is an introduction to sequences and series, we're actually going to talk very, very little about a series. A series is when you're adding an infinite number of values. And so we talked a little bit in the previous class about a partial sum adding, say, 10 numbers, and a series where it's not a partial sum, it's not a sum of a finite number of values. A series is a sum of numbers, a list of numbers that never ends. You're adding by not an infinite number of values, not 100, not 1,000, not 1,000,000, but the addition never stops. And for pre-calculus, the only type of series that we're going to be talking about will have to be something of a geometric series setting, which will be tomorrow. Excuse me, not tomorrow, but Friday. So when you recognize that you have a list of numbers that are created by a common difference, say it's just a very simple example, we have a sub 1, which is equal to 2, a sub 2, which is, I'm going to constantly add by something here, we'll hopefully figure it out, 5, a sub 3 is going to be equal to 8, a sub 4 is going to be 2, 5, 8, oh my gosh, 11. And that list of values continues. When you realize that you have a common difference, a D, which will be identified as that common difference, that's your indication, that is your discovery that the numbers you're dealing with, the sequence that you're dealing with, is an arithmetic sequence. Now, if I say you have this list of numbers of 2, 5, 8, and 11, in the previous section, we had a couple of homework problems that I anticipate tomorrow getting a few questions about, the more complicated ones. We were given a list of numbers and asked to come up with a general term. And we talked about if the first differences are constant, it'll be a linear function. If the second differences are constant, it'll be quadratic. Maybe it might have a sequence that is involving factorials or powers. But when you have that common difference, your general term is a sub n is equal to a sub 1 plus a common difference times n minus 1. it's such a common type of sequence in mathematics that we go ahead and just say, okay, you figured it out on your own a few times. Here is just simply the general term. So maybe we have an example that is something like, well, let's just work off of one we already have. Given this list of values of 2, 5, 8, and 11, write the general term of that sequence. And if you recognize, as we already have, 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, as soon as you identify that you have that arithmetic sequence situation because you found a common difference, you could just write the general term through the memorization of this formula, that a sub n for this given sequence of values is equal to the first term in the sequence. Well, what was a sub 1? 2. You almost immediately notice I was adding by 3, so we have a common difference of 3, and then that is multiplied by n minus 1. Is there anyone not sure of where the n minus 1 is coming from the previous sections of homework? We cool with the n minus 1, or you want that explained? Explained? So when we're given a list of numbers and we're being told that that list of numbers is, a sequence of numbers, I don't generally specifically, identify this as a sub 1, a sub 2, a sub 3, a sub 4. You just have a list of numbers of 2, 5, 8, and 11, and so on and so on. And once you see that plus 3, that plus 3, that plus 3, I bet you can tell me what a sub 5 is really quick. 14. But that idea of just, I just add 3 to the previous number is recursive. Okay? When you want a general term or explicit formula, you want to be able to get to a sub 5 not by adding 3 to 11, but doing some kind of arithmetic with the very first number in the list. So you start asking yourself, you should be asking yourself, for the second term in the list, how many times did we add? Once. To get to the third term in the list, how many times did we add by 3? How many times did we add 3 to the first term? Twice. To get to the fourth term in the list, how many times did we add 3, not to the previous number, not recursively, but adding 3 to the very first number? That was 3. So the subscript is your n. And when n is 2, you added 3 once. When n was 3, you added 3 twice. When n was 4, you added 3 times, or n minus 1. So that's where the n minus 1 is coming from, is you looking at, I want to get to the fourth term. I understand that I'm repeatedly doing some kind of constant, in this case addition. In the future, it might be multiplication or division. And you're asking yourself, how many times did you do that repetitive math from the first term? And that's where the n minus 1 comes from. Now, you may want to simplify this. I would not need you to necessarily on say a homework or test question problem. But you may want to simplify this. Distribute the 3, and we have a sub n is equal to 2 plus 3n minus 3. Combining like terms, and you have a sub n is equal to 3n minus 1, of course, because 2 minus 3 is negative 1. And you may, if you so desire, see that there is a relationship between this arithmetic sequence idea that we're just starting to see for the first time, at least in name, and something you've studied in the past, which was brought up by the teacher from the previous period. That was actually handwriting you guys were asking about. I just wanted to get started. I want to do a lot of examples today, not a lot of rambling on about theories and concepts. What does this look like? It looks like a linear function. It looks like y is equal to mx plus b. So indeed, graphing an arithmetic sequence would be probably like what you would have done with t-tables, because most people don't make t-tables with fractions. When you have that y-intercept, and maybe you plug in you know, say an x value of 0. Of course, that wouldn't work for a sequence because the domain is positive integers. And then you plug in that x value of 1 and the x value of 2 and the x value of 3 and the x value of 4. And you'd be seeing a line with a slope of 3 and a y-intercept of -1. And, you know, maybe not really thinking about it, excluding the x value of 0, but you could be sort of graphing a sequence, an arithmetic sequence, that you could then later, of course, and this is what you probably did with t-tables when you first started learning lines, equations of lines and graphing lines. And you probably just swiped a straight line through those, and then you went from graphing a sequence to graphing a linear function. But they're, you know, they're very, very similar. They're actually exactly the same except for the domain. Well, is that cool? So what if, now that we see that a sub n is equal to a sub 1 plus d times n minus 1, the general term of an arithmetic sequence, what if you have a question that gives you this information? Write the general term. What is the general term of the given arithmetic sequence? And you're told that a sub 6 is 26 and a sub 10 is 42. Not the simplest of questions, because your general term is asking for what? A sub 1 and a common difference. And what are you given? Do you have a sub 1? No, you have a sub 6 and a sub 10. So you're going to have to, like, you know, get a strong understanding of what's going on and understand that when you're told that something is arithmetic, you're told that you're doing what math operation to create the numbers in the list? It's a constant what? It's a constant addition, you know, of a common difference. So play around with that for a few minutes with your table mates. You know, what is that common difference? What are you repetitively adding by to create this list of numbers? Someone give me just anything you've done. I'm not sure if that was enough time for us to, you know, all come up with a general term yet, but just something that you started this process with.
I subtracted 42 by 26.
Okay. So we got solution process number 1, where we got 42 minus 26, which was 16. Okay.
By 4, because that's the amount of terms in between 6 and 10.
So you divided by 4 because you knew that was the number of terms. Now, if you're really visual like I am, so this is sort of like a pseudo but very similar sort of second process, is a sub 6 is 26, and then there's a sub 7, a sub 8, a sub 9, and then I might be the person that needs to, you know, especially in the beginning when I'm doing my very first one, that either in a year, I haven't taught this necessarily in a year, even that's sort of kind of a lie, because this threads through my other courses that I teach. But you might actually have to draw it out and go, oh, there's 1, 2, 3, there are 4 sums of some common difference. So what's the 4 represent then? The common difference. All right, so we got D is equal to 4. Well, that is not the general term yet. So someone else maybe you want to pick that up? How would we use the fact that this has now helped us find the common difference of 4? How would we extend that to finish this problem up? Do you want to work with a sub 6 or a sub 10? When you said the formula, do you mean this formula?
Yeah.
Okay, so we need an a sub n. So we have a sub 6 is 26, or you know a sub 10 is 42. Which one do you want to work with?
I just found a sub
Okay, how'd you do that?
1. I just like literally just wrote them out. And just,
Oh, so you took this like expansion here and just kept going backwards.
yeah.
Nothing wrong with that. So Naya's saying, well, I know a sub 6 is 26. Let's just subtract 4 to get to a sub 5, subtract 4 to get to a sub 4, and continually subtract backwards until you get to a sub 1. That's absolutely a very valid process. What if this were like a sub 60, though? That would be a really long list. So
You could plug in a sub 6 into the formula to find a sub 1.
So a sub n is the first term a sub 1 plus our common difference, which we now know is 4. And when we say a sub 6, we are identifying that we know that n is equal to 6. So we can say a sub 6 is equal to a sub 1, I'm just going to write up for notes, plus d times n minus 1. But when I write a sub 6, I am saying that n is 6. And we also know that a sub 6 is 26. So we have 26 is equal to a sub 1 plus d, which is 4, times 6 minus 1. So we've got, I didn't make a mistake, did I?
No.
Okay, so then we have 26 is equal to a sub 1. We got 6 minus 1, of course, is 5, times 4 is 20. And then subtracting both sides by 20, we get 6 is equal to a sub 1. This has helped us come up with a sub 1 and d, which means if you know a sub 1 and you know d, then you know that a sub n is 6 plus 4 times n minus 1. There is a completely, it's not fundamentally different, but it sure sounds different. What did, honestly, and it was, again, a student of mine in the previous class that kind of like made me go a little, aha. I mean, I knew this, but I hadn't thought about it for a long time. Arithmetic sequences are just lines, but with a domain of positive integers instead of a domain of all real numbers. What would be, everybody good with this? Because I'm going to erase it. If there is such a close relationship, if there's such a close relationship between arithmetic sequences and lines, you could think of this as two coordinates of a line. What would be this coordinate?
626.
This would be, now the coordinate's not x and y, it's sort of like n and a sub n. But you have a coordinate of 6, 26, and a coordinate of 42, and 10 and 42. And the slope, the rate of change of the line will be the common difference between those positive. What is the slope? What is the definition of slope? Wrong. It's rise over run is only good for like drawing lines. It's not the true definition of slope. That's still y sub 2 minus, that's the same thing with different words. Delta y over delta x is still rise over run. Real definition of slope is the change in y per 1 unit of change in x. When you're doing word problems and you're talking about like the pitch of a roof, the steepness of stairs, the slope of gutters underneath the ground so that everything doesn't back up into your house when you flush the toilet, like someone uses gradient or slope all the time in building everywhere. It's all over like building codes. Besides, rocket science and all the other stuff. So the real definition of slope, if you're doing a word problem and you want to interpret what that word problem means in terms of the real world, like It's the rate, it's the amount of change in y per 1 unit of change in x. Well, what's the domain of sequences? Positive integers. 3, 4, 5, 6, 7, 8. What's the difference between your n values? 1. That's what slope is. The change in y, in this case, or in this case, the change in a sub n per 1 unit of change in x, or in this case, 1 unit of change in n. So when we find the slope between these 2 points, we are finding the common difference. So at any rate, I can see I'm losing a couple of you. 42 minus 26 over 10 minus 6. I'm not sure if was thinking a slope formula when he said subtract and divide by 4, but that's exactly what he did. So 42, 22 minus 6 is 16. 10 minus 6 is 4. And there's your slope. There's your common difference of 4. And then, of course, we would repeat the process with a sub 6 being equal to 26. But that's another way of kind of like seeing what your common difference is.
For a sequence, could it ever like fluctuate like curve?
Not in a curve per se, but there is such a thing as alternating sequences. We're not going to study it. We'll see them a little bit, actually. Let me rephrase that. We might see alternating series in a format. I'm not going to give it as a definition. We're not going to thoroughly study alternating series, but it is a type of geometric sequence in series. So yes, it won't be a wave because it's not ever going to be a smooth sine wave like a curve because the domain's only integers, but we will alternate it between positive and negative numbers. Yep. Okay, so this is a little bit of insight into how to write out terms of arithmetic sequences and how to come up with a general term. Let's talk about partial sums. Okay, so let's say we've got 3, 5, 7, 9, bless you, 11, and 13. And we've got this list of numbers. Is it arithmetic? Why is it arithmetic? Because we're constantly adding by 2. So boom, we got a sub 1 is equal to 3. We have a common difference of 2. So therefore, we do have an arithmetic sequence. And let's just say that I want to add these first 6 numbers up. I want to find s sub 6. Well, that is 3 plus 5 plus 7 plus 9 plus 11 plus 13. Now I'm pausing. I'm not going to do this right now because there's something else I want to talk about. But when we introduce sigma notation, I do realize that I never gave you, that's in the homework though, we didn't talk about any problems that gave you a partial sum and asked you to write it into sigma notation. We need to do that. If I have time today, I will, but I might not. So we'll definitely visit it tomorrow. So what is the sum of these 6 numbers? Well, I know we can all add this up, and some of you are already trying to give me the answer. But I want you to understand how to do this problem in a way that will allow you to rederive the formula if you forget it, because I'm about to give you a partial sum formula, and a formula that would work if you wanted to add 1,000 numbers, not just 6. We can all do this in our head. So let's use this simple example to understand how to do something a lot more complex that's got maybe hundreds, if not thousands and thousands of numbers. How could you quickly find a partial sum of an arithmetic sequence? Okay, well, I'm not going to give you any time for discovery. I'm just going to write this out. What I'm going to do is I'm going to take this 13 and bring it underneath the 3. So I'm putting the largest number underneath the smallest number. I'm going to take the 11 and bring it under the 5. And I'm going to bring the 9 and bring it underneath the 7. So I'm taking the second half of this list and I'm reversing the order and putting it underneath the first half of the list. Why am I doing that? Anybody see what's going to happen? We will have multiplication show up here in a second, but if I...
If you add the columns, they add up to 16.
Yeah, if I add straight down, I'm going to get the same answer over and over again. We're going to get 3 plus 13 is 16. 5 plus 11 is 16. 7 plus 9 is 16. And I'm writing plus signs between all three of these because the whole point here is to find the sum. I've got repeated addition of 16, which is, of course, is 3 times 16. And the answer is 3 times 10 is 30, plus 3 times 6 is 18. The final answer is going to be 48. So when you have a list of numbers that are arithmetic, that's really freaking cool. If you reverse the order of the second half of the list of numbers and bring it underneath the first half, those columns will always add to the same number. Now, how many numbers, I think that's pretty dang cool. How many numbers did we start off with?
16.
Yeah, it's right there. It's 6 numbers. Once we flipped the order around and added, how many numbers did we end up with? 3. So that's a pattern that's going to hold consistently. And in using the most clearly identifiable numbers in the sequence, how did we get 16? Yes, I added 11 and 5, and I added 9 and 7, but these are all like numbers are kind of like in the middle. And if there's thousands of numbers, I might not know all the numbers in the middle. It's the first and the last. So partial sum formula, S sub n is n over 2 times a sub 1 plus a sub n. You'll want to memorize that formula or rebuild it, like I just did. That's partial sum for an arithmetic sequence. So let's do an example off of that. We'll do one pretty basic, and then just to kind of get you all excited for what you might see at the end of IB Mathematics, which is what we're in, we'll look at a more fun problem. Yay! I love fun problems! Okay, so let's take a look at, not the world's hardest problem, but let's take a look at this example. So find the partial sum given 0, negative 9, negative 18, negative 27. This list is going to continue for ... arguably forever. And n is equal to 40. So in other words, if n is equal to 40, I want to find the sum of the first 40 numbers. So what is the partial sum formula asking for? What's S sub n equal to? Yes. What's it equal to? What's on the right-hand side of the equal sign? N. Oh, okay. We know what n is. It's 40. So 40 over 2.
Plus 0.
Well, times a sub 1, which is 0, plus a sub n, or a sub 40. Okay, so we need to figure out what a sub 40 is before we finish this problem. So a sub 40, thank you. So we fed the formula, and we're going to let that missing piece tell us now what to do. We need to know what a sub 40 is. So a sub 40 is equal to, and I'm using my general term formula right now, a sub n, a sub 40 is equal to a sub 1, which is 0, plus, we need a common difference. So plus, what's our common difference? Yep, negative 9. So actually, instead of a plus, I'm going to write minus 9 times 40 minus n minus 1, 40 minus 1. So we have, thank you, I'm going to take that in a second. Negative 9 times 39 is negative 351? Okay. Thank you. So we've got our partial sum is equal to 40 divided by 2 is 20 times 0 minus negative 7,020. Bam! There you go. Partial sums. Yeah. Okay. I think I might have to finish this after the bell rings, but I'm going to keep going. Did you just groan because I said I was going to do another example?
You're talking to me?
I'm talking to whoever just groaned. The fifth term of an arithmetic sequence is 6, and the sum of the first 12 terms is 45. Find the first term and the common difference. Figure it out.
Okay.
You've got all the formulas you need. Just feed the formulas. Set up and then feed the formulas. Let them tell you, let the work and the formulas tell you what you need to do. Okay, so let's take a look at this. Again, we have the fifth term of an arithmetic sequence is 6, and the sum of the first 12 terms is 45. Find the first term, and D. We don't have a whole lot of information given to us in this problem, so it's a lot more interesting, a lot more fun than maybe sort of just a standard textbook problem. When you see a question that is just sort of got an interesting twist to it and gives you a little bit less information, kind of like it's more of a puzzle problem, set the formulas up for the information given and let those formulas feed and ask you actually what they need to be fed. So the fifth term of an arithmetic sequence. Okay, so we're told it's arithmetic and we're given a fifth term. So we can use this general term of an arithmetic sequence and see that we have a sub n, which is, well, for the fifth term going to be a sub 5, is equal to a sub 1. Now, as I reread the problem, I don't know what a sub 1 is, but I'm given the fifth term, I'm given a sub 5, I'm going to need that formula, if not an actual numerical value, to lead me through the rest of the problem. So a sub 5 is equal to 6, and that is equal to a sub 1 plus our unknown common difference. We don't know that yet, but we do know here that we got a sub 1 plus d times n minus 1. Well, when they tell us that a sub 5 is 6, they're telling us that n is equal to 5. So we have 6 is equal to a sub 1 plus d times 5 minus 1. And cleaning this up, we get 6 is equal to a sub 1 plus 4d. And, well, that's all we have. So let's leave that there for a moment, because I don't know what else to do with this. I don't know if I need to know what a sub 1 is or d, but at least I have an expression relating the variable of a sub 1 and d together by the fact that a sub 5 is equal to 6, and I'm using that general term formula. What else is given in the problem? They tell us that the sum of the first 12 terms is equal to 45, and we just happen to, unless I erased it, I did, we happen to know that the partial sum s sub n is equal to n over 2 times a sub 1 plus a sub n. So we are told that we have a partial sum, which tells us a lot. It's the sum of the first 12 terms. So we have s sub 12. Okay, as soon as I write s sub 12, I am recognizing that n is equal to 12. So we have s sub 12 is n, 12 over 2, and then that's times a sub 1, okay, we don't know what a sub 1 is in our problem, plus a sub n. Well, I'm writing a sub n, but if I'm finding the partial sum of the first 12 terms, then I know that n is 12 and this is a sub 12. So we're going to have to figure that out in a minute. So s sub 12 is equal to n of 12 over 2 times a sub 1 plus a sub 12, and that is equal to 45. Well, right now, between our black formula for a sub 5 and our blue formula for s sub 12, I've got 3 unknowns. I've got a sub 1 and d and a sub 12. Well, when you have two equations and three unknowns, that very well could be a problem. So let's figure out what else we can do here. This partial sum formula is asking for a sub 12. And again, we have this general term formula that says a sub n. So we'll have a sub 12 is equal to a sub 1. Okay, we don't know that yet, but let's feed the formulas. A sub 1 plus common difference. Nope, don't know that yet. So d times, okay, n minus 1. Well, for this formula, when I write a sub 12, I'm saying that n is 12. So we're going to have d times 12 minus 1. So now we have a sub 12 is equal to a sub 1 plus, oh, now this is starting to look promising, a sub d. We can write a sub 12 as a sub 1 plus 11d, and I've got another black formula that also is using the variables of a sub 1 and d. So we can kind of eliminate this third unknown of a sub 12. So we've got 12 divided by 2 is 6 times a sub 1. Oh, okay, now see, this is asking for a sub 1, and I need to manipulate this equation of 6 is equal to a sub 1 plus 4d to get it set up so I can add it into this or substitute it into this partial sub formula. Hey!
Oh, I wore yellow today.
Oh my God, we have to do a selfie. Don't be. You're awesome. All day I didn't even notice that, and I'm the one that told you we're yellow. So we are going to write, and we're going to figure out what a sub 1 is in terms of the fact that we were told that a sub 5 is equal to 6. So a sub 1, bring in the 4d over with subtraction, we have 6 minus 4d is equal to a sub 1. And taking this unknown of a sub 1 out, we can substitute in 6 minus 4d. Now we have plus a sub 12. We know a sub 12 is a sub 1 plus 11d. So a sub 12 is going to come out. And in its place, we have a sub 1 plus 11d. And some of you are probably right now trying to, yell at the camera telling me to, well, wait a minute. I had an a sub 1. I've replaced it with a term in an expression in terms of d. And I'm reintroducing another a sub 1. This is just how I'm working the problem this time. If I were to show you my notes from the first time I did this question many, many years ago, I'm doing the same thing I did years ago, which is working with systems of equations using substitution. I'm just working it in a slightly different process, but it all comes out to be the same. So you can be creative in how you show the steps for these problems. At their core, there has to be some commonality in the logic of what you're doing. But what I'm going to do now is, okay, a sub 1 was replaced with 6 minus 4d. And when I did the substitution for a sub 12, which was equal to a sub 1 plus 11d, I sort of like introduced another location of an a sub 1 variable here. But I can just do the substitution again, remembering that a sub 1 is 6 minus 4d. So that is going to give us a 6 minus 4d plus, now here where we have an a sub 1, I'm going to repeat that substitution again and say that a sub 1 is 6 minus 4d. And then plus 11d. Now hopefully I can do this without running out of space. Let's clean this up a little bit. We've got 6 times, okay, we've got 6 plus 6 is 12. We've got negative 4d. Negative 4d is negative 8d plus 11d is 3d is equal to 45. I would like to right now just divide both sides by 6, which arguably I could, but that's going to introduce a fraction. Ultimately, our answer is going to be a fraction, but I don't want to introduce fractions any earlier than I need to. So I'm going to distribute the 6 through. Maybe you would like to do it slightly different, and that's okay. 6 times 12 is 72 plus 18d from the 3 times 6, or 6 times 3, is equal to 45. Got a lot of equal signs here. Let me take these out. That's not kind of making any sense there, is it? Okay, there we go. Clean up the notation a little bit. Let's bring the 72 over with subtraction and get 18d, 45. Let's see here, 72 minus 40 is going to be 32, minus 5 is going to be 27, only negative because we're bringing the 27 over. So we have negative 27. And then dividing by d, or dividing both sides of the equation by 18, we have d is equal to negative 27 over 18, or d is equal to negative 3/2. And we have solved half of this, pretty complex problem here. We were asked to find the first term and d. Well, now we know that d is negative 3/2, and we have a sub 1 is 6 minus 4 times d. So I've got a formula here set up to help me find the first term in this arithmetic sequence. But I need to make some room here. So we have a sub 1 is 6 minus 4 times our common difference that we now know is negative 3/2. Of course, negative times negative is positive. We got 4 divided by 2 is equal to 2. And 2 times 3 is equal to 6. So we have a sub 1 is 6 plus 6. And that means our first term in this arithmetic sequence is 12. And the common difference is negative 3/2. And I'm Mr. Tarrou. Bang! Go do your homework.